In the previous video, we worked through the free response question 4 of the 2009 AP Calculus BC exam, and we did part A. Well, in this video, we're going to do part B, and part B shouldn't take too long, so I think we're also going to get to part C. But for now, let's focus on part B. Part B asks, at the point -1, 2, the second derivative of y with respect to x equals -12. So that's asserting. And then find the second degree Taylor polynomial of f of x around -1. So this is the question. What is this second degree Taylor polynomial? Well, you can recall that, what is the general second degree Taylor polynomial? It says that any function f of x is approximately, if we're approximating around -1, we're going to say f of -1 first, and that's the constant term. And then for the linear term, we say plus whatever the derivative of f at -1 is, times x around -1, which is x plus 1. We're adding 1 to shift everything to the right so that we reach -1. And then for the quadratic term, you say plus the second derivative of f around -1 divided by 2 factorial, which is just 2 also, so we can remove the factorial. And this is multiplied by x plus 1 squared. Well, with the general form of the second degree Taylor polynomial in place, all that's left to do is substitute things in. And we are fortunate to have many of these values on hand. So let's write out our final answer. F of x approximately equals, f of -1, what's that? If we recall, f of -1 equals 2, just from the statement of the problem itself. So that's solved. F of x is approximately 2 plus, what is the first derivative of f at -1? Well, if we recall from the previous part of the problem, we actually solved that for the first of our 2 equal steps of Euler's method. The derivative of y with respect to x at -1, 2 is 6 minus 2 is 4. So we know that first derivative also, so we say 4 times x plus 1. And here we say the second derivative at -1, which they give us as -12 divided by 2. Well, -12 divided by 2 is -6, so we say minus 6 times x plus 1 squared. And this is our final solution. Not too bad. Mostly just substituting things in. And now for part C. So, part C asks to find the particular solution to the differential equation given that f of -1 equals 2. So it's giving us this initial condition that we've worked with throughout the problem, so we're already a bit familiar with it, and to find the particular solution. So if we would recall up here, I'll just copy and paste it to make things simple. We have this differential equation that dy dx equals 6x squared minus x squared y, and we're going to be solving this in this problem. And the first thing that might come to your mind when you're taking an AP Calculus BC test and they ask you to solve for a differential equation is, can I separate it? The AP Calculus test makers love their separable differential equations, and indeed, this differential equation is separable. So what do I mean by that? I mean that we can take it apart into a multiplication of just x's and then a function of just y's. So how can we do that? We can rewrite it like this. We can say dy dx equals, and then factor out the x squared. So you get x squared times 6 minus y. And you see here, we have a function of just x's and a function of just y's. And at this point, we can be ready for an integral by doing this. We can multiply by dx and divide by 6 minus y. So we say 1 divided by 6 minus y dy equals x squared dx. So we multiply by dx, divided by 6 minus y, and now it's prime time for integrals. So we can throw up our integrals with the integral of this equals the integral of this, and we can start solving. So what is the integral of 1 divided by 6 minus y dy? Well, it is the natural log of this. We have to remember that because of the chain rule and the derivative, we'll get a negative, so we have to counteract that with a negative of our own. So we say the negative natural log of 6 minus y. And we can put in a plus c here just to be safe so we don't forget it. And the reason, again, that we have this negative is because if we were to take the derivative of this side, we would get 1 divided by 6 minus y is the derivative of the outside, times the chain rule derivative of the inside is the derivative of 6 minus y is negative 1. And in order to cancel out that negative 1, we add on our own negative 1. So with the left side out of the way, let's move on to the right side. The integral of x squared dx is simply x cubed divided by 3. And we do not need to add a constant of integration because it would simply be reabsorbed into the left constant integration here. With this, we can remember our initial condition, f of negative 1 equals 2, to solve for c. So f of negative 1 equals 2 means that when you plug in x equals negative 1, you get y equals 2. So let's plug these in. We get the negative natural log of 6 minus, we're told that the y is 2 plus c equals, well, the x is negative 1. Negative 1 cubed is still negative 1. Get negative 1 divided by 3. And here we say that this is the negative natural log. 6 minus 2 is 4. And this plus c equals negative 1/3. Now, I realize if we're going to go back a little bit, to be extra specific and correct here, we could write all of these parentheses as natural log symbols. Not natural logs, but take the natural log of the absolute value. So we could write these all as absolute values here to be especially correct, but it will turn out to not matter because we're not going to be encountering any negative signs along the way. But this is good practice, and I gotta remember to do it myself sometimes. So with these natural logs with the absolute values, and here we just have a simple equation to solve for c. So if we add natural log of 4 to both sides, we get that c equals negative 1/3 plus the natural log, well, absolute value of 4, that's just 4, so the natural log of 4. So this is the particular solution we're going to be using. But before we apply it, we've actually got to solve the equation itself. So if we come right back up here to this point here where we had this equation, let's remember what we were doing. Well, the plan was to actually solve for y. So first thing we can do there is get the constant to the other side. So I'm going to switch back to my red color. We can subtract this constant. So we're going to get the negative natural log of 6 minus y. But this is subtracting an arbitrary constant, and arbitrary constant times negative 1 is still an arbitrary constant. So this is going to turn into just x cubed divided by 3, again, plus another arbitrary constant, right? C1 maybe, which is, we know, negative 1 times c, but it doesn't really matter. It's the same thing. So now we can multiply both sides by negative 1 to get rid of this negative sign here, and we get the natural log, and I'm reverting my old ways of parentheses. Technically, we are still in natural log phase because we cannot plug in a negative number to this natural log. In the end, we'll see that doesn't matter, but for now, we'll use the absolute value. So the natural log of the absolute value of 6 minus y equals negative x cubed divided by 3. And again, we're multiplying this by negative 1 again, so we can call this a new constant, c2. Again, arbitrary constant times something is still an arbitrary constant. From here, we can simply raise each side to the power of e, and we will get that e to the absolute value of 6 minus y, which is just the absolute value of 6 minus y, equals e to the right side. So e to the negative x cubed divided by 3 plus c2. But it's important to remember that when you have e to the negative x, when you have e to something plus another something, that is the same thing as e to the power of the first something, so e to the c2, times e to the power of the second thing, e to the x cubed divided by 3, negative x cubed divided by 3. Scroll down here for some space, and, well, e to the power of a constant is another constant. So we can rewrite this one more time as the absolute value of 6 minus y equals yet another constant times e to the negative x cubed divided by 3. And finally, we can go ahead and solve this. So we did some weird things to our constant, so just to be safe, I'm actually going to recompute this very quickly. So when x is -1 and y is 2 is going to be the condition for C3. And when you're actually taking the test, you should probably compute your constant once you're done with all your algebraic manipulations, just to be safe. So I didn't do that, so learn from your mistakes, but that's fine. So as we remember, y is 2 when x is -1. So the absolute value of 6 minus 2 equals C3 times e to the -1 cubed again is -1. So divided by 3. This tells us that, 6 minus 2 is 4. Absolute value of 4 is just 4. 4 equals C3 times e to the 1/3. E to the 1/3. And if we divide 1/3, that's the same as multiplying by e to the -1/3. So we get that C3 equals 4 times e to the -1/3. So we're getting slightly different c's, and when you're actually taking the test, you should probably either solve for the c after you're finished with your algebraic manipulations, or plug the c in as soon as you've solved for it so your algebraic manipulations don't mess it up. But with this all out of the way, we can plug this back into our general solution, and I'm going to do it over here so we know specifically we have our particular solution. This is our particular solution. I'm running out of space, I'll abbreviate that. And we can take out the absolute value here. So we get that 6 minus y equals, we plug in C3, 4e to the -1/3 times e to the -x cubed divided by 3. And we can do a couple of things here. First thing we can do is we can subtract this 6. So we can say y equals -6 plus 4. And the second thing we can do is we can say, we're saying e to the power of something times e to the power of something. And we can say this is equal to the e to the power of the first thing plus the second thing. That is how exponentiation works. So we can say e to the, and we can also take out the factor of -1/3. So we can say -1/3 times, and then we have here then x cubed plus 1, because this plus 1 goes to -1/3, and the x cubed goes to -x cubed divided by 3. And from here, all we're left to do is divide by -1, and we have our particular solution. Y equals -6 goes to 6, 4 goes to -4, e to the -1/3 times the quantity x cubed plus 1. And this here is the final particular solution, and that was free response question 4 of the 2009 AP Calculus BC exam. I will see you in the next video.